Hello, this is James from xrobots.co.uk. This is a short vlog. I have an update about the slicing software called Slicer, which is part of the 3D printing toolchain. So here's my 3D printer. This is a Lulzbot Taz. This is a very special one because it has dual extruders. So we have two hot ends and we have two materials fed in. So one of the examples I showed you previously was a wheel printed in one go with the hub rigid and the tyre printed on it in the same print in NinjaFlex rubber. In the previous version of Slicer, it was a bit of a muddle to try and combine the two materials into one print. It wasn't as flexible as I'd like it to be. There's now been another release to Slicer, which handles multi-material prints much better, as well as a lot of other features. So let's have a look at the software. So the way this works is that we start with a piece of CAD software. I'm using Autodesk 123D Design here, which is free software. We use that to design the part. In this case, we've got the wheel with its tyre on. These are actually two separate pieces, so the hub there, if we just hide it, is a separate piece in the assembly. What we'd have to do here is export these as two files, so we'd export them as two STL files for 3D printing. We could also export a multi-material AMF file, but Autodesk 123D Design isn't actually capable of that, so we have to use two separate STLs. Previously, when we come over to Slicer to combine those parts for printing, we'd have used the menu option that says Combine Multi-Material STL Files. First of all, we'd have gone and got the ABS one, and then we'd have got the NinjaFlex one, and then once we click cancel, it prompts us to save it. In fact, I've already saved the AMF file, so it makes the multi-material part for you, and then we go and get that AMF file and drag it into Slicer, and once it's processed that, we can have a look at it, and that would give us the multi-material part. So we can assign each part to a different extruder, which we can see on the right here. I've got one set up for ABS and one for NinjaFlex, and that's basically how we printed the parts before. The only challenge is we only get one set of print settings, so we only get one set of layer height, one set of infill density, so we can choose to infill the parts as we wish, so we can have different patterns like honeycomb. We can also select the percentage, but there's only one set of settings, so we have to do the NinjaFlex and the plastic with the same set of infill, and we also have to print at the same speed for each part. There's only one set of speed settings. This was kind of a bit inflexible, although it worked to print the parts. So let's get rid of that. Now what we can in fact do, this is actually the latest version of Slicer, which is 1.1.6 at the time of recording. This has got another option where we can actually vary the settings per part. We also don't need to use the combined multi-material STL file menu option to make an AMF file. We can just import two STLs. So basically, if we start with the ABS one and we just drag that in as usual, let's just quickly have a look at that. So there's the middle of the wheel. And now if we go to the settings menu, we've actually got a whole lot of other settings, so we can then go and load further parts. So I'm going to now load the NinjaFlex part, and that'll do the combining for you. And now we've got a whole set of settings, so we can say, well, the inside, I want the default extruder to be extruder 1. I want that to have an infill density of, I don't know, let's see, yeah, 40% will do actually, and I want that to be infilled. The infill pattern, I want that to be honeycomb, and then I can go and look at the other part and I can say, well, actually I want that to print on the second extruder. I want the infill density to be only 10%, and I want the pattern to be rectilinear. So we've got those two sets of settings, one in 40% honeycomb for the middle and one in 10% rectilinear, which is lots of lines, for the rubber. And obviously we can have these in different densities and different infills, so we can make the rubber much softer, and we could make maybe the hub in totally solid plastic if we wanted. So the only thing we need to remember is to go and go back to infill here and set that to 0 on the default settings, otherwise it will ignore the other settings we just set. And I should also point out that's not the only thing you can change. There's a whole bunch of basically every parameter can be changed for each piece. So I've already generated the G-code for that, so let's have a look and see what it looks like. So I'm using a G-code viewer, which you can find at buildlog.net/gview. and this is basically visually interpreting the G-code. So the G-code is basically the data that controls the printer. So it's a file that in my case you put on an SD card in the TAS, or you know, use the software that comes with your 3D printer, or you'd use Pronterface or something to drive the printer over USB. And the printer follows the G-code blindly, so in this visualization the blue lines are moves and the white lines are extrusions. So this is a visual representation of what's actually going to get printed. So we should be able to see that we've got the honeycomb in the middle there. We can see all of the little sort of round cells inside, and we can see on the outside we've hopefully got rectilinear, which is a crisscross pattern. So let's just zoom in on that a bit, and we can see there, yeah, on the outside it's just a crisscross, and in the middle there you can see the honeycomb, so that's worked perfectly. And the other thing we can do with this settings menu in Slicer is load a modifier. So we can load yet another STL which intersects one of the first ones. We don't necessarily need to have dual extruders for this. We could load one STL and then just have another one that intersects it. And then we can set all of the same settings, such as infill and the speed and all of the different settings for that, for those pieces that intersect. So in this case we could load another STL that perhaps intersects every other tread on the tyre, and then we could change the infill again for that, so we can have every other tread could be much softer by using a lower density infill. So even with one material that's quite useful to specify what the printing parameters are for different sections of the print. So that makes Slicer quite a lot more flexible than it used to be. So another good feature in this version of Slicer is a new type of support material called pillars. So if I was to try and print an object like this with either an overhang or a bridge in it, obviously I'd actually turn this piece upside down and print the flat down on the print bed and leave the legs sticking upwards. But let's just say I'm going to print it like this, so we can force Slicer to put some support material underneath. Obviously the bridge piece there, we can't print on air, so basically we're going to get Slicer to hold that up with some scaffolds. So I've got the piece in Slicer here. Here it is. And if we go here and have a look at support material, and we tick support material, if we leave the overhang threshold to 0, it automatically works it out for you. And the options for support material, we've got various, the previous ones were the top 3, and we've now got this new one called pillars. So let me show you the results between rectilinear and pillars. So this is the result with rectilinear support material. So you can see that we've got the bridge there, but the underneath of it's completely filled in with effectively a zigzag pattern, which is the support material. So that's there just basically to hold up the prints when it comes to do the bridge piece. That takes quite a long time because it's filled in, well, it's not solid, but it's filled in with, you know, almost the same as say a 20% rectilinear infill. So that's quite time consuming, and also it takes quite a bit sometimes to snap the support material out afterwards, unless of course you've got water soluble support material or something like that, which requires dual extruders. This is the example using pillars. So you can see here that it uses these nice tree-shaped things. So the stalk on them is much smaller, and they bridge out towards the top to hold the bridge part up. So it looks a bit like some sort of Roman building, but basically it means those parts are much easier to remove. There's much less material used, which makes it quicker to print and ultimately cheaper. So those are a couple of my favourite features in this new version. It's worth having a look at the Slicer website and having a look at the release notes, because there is actually some more new stuff in there. So if we go here and look at the previous versions, basically 1.16 is a roll-up of the previous versions with some bug fixes. So most of the good stuff happened in 1.10. So we've got also linear gap fill. So for doing the infill in lots of small places, you used to find the printer vibrated a lot because it used to try and fill it in with zigzags. What they've done now is made sure it fills it in with just lines, as indicated by the green region here, by just doing a fatter extrusion to fill in the gap. So that's quite a good improvement. The object editor I showed you there, modifier meshes, and the pillars support material. I believe there's some other good stuff that went on. Yeah, 112, so there's a cutting feature as well, so you can slice an object up in there. And also they've done some more experiments with the support material for doing bridging. So instead of putting support material underneath where there's a big bridge, it's got the ability not to, and intelligently kind of stretch the filament across. Because depending on what the settings you put in, sometimes you can actually get away with a bridge if it's not too big. So that's all I've got for this time. Don't forget to subscribe to my channel for updates on my actual projects. Check out my social media pages in the description to this video.